Okay, here's a video for 2HT about exercise 24 and exercise 25 from the general revision. These questions are about chapter 2, and if you remember, chapter 2 were about calculating the areas of triangles and other shapes. This exercise is mostly about triangles, so I want to write down how to calculate the area of a triangle, and that's a half times a side times the matching height. Now for exercise A, we need to calculate the area of triangle EBC, so that's this triangle over here. Now this triangle has three sides, EC, BC or BE, right? But we know only one side, we only know that this is 2.5. And this is the matching height, because the height always needs to be perpendicular to this side. And if you make this side longer, you can see that here it intersects that one, and the angle is 90 degrees. So to calculate the area for triangle EBC, we do a half times this side, so times 2.5, times the matching height. And if you calculate that, you get 3.75 squared centimeters. Let me make sure everything fits on the screen. So this is how to calculate A. Then we're going to go to exercise B. And exercise B is triangle EFC. Alright. So if you want to calculate triangle, the area of triangle EFC, so it's E is here, F is there, and C is there, right? We don't know any of the sides, so we need to figure something out. Well, we can actually figure out what that side is, FC, because you know that this length from A to B is 4.5. And this shape is a parallelogram. That means that this length is also 4.5. So if you do 4.5 minus 1.5, you know that this length should be 3. So if you want to calculate the area of this triangle, you do a half times 3 times the matching height. And the matching height is also 3. So there you get 4.5 squared centimeters. That's the area for triangle EFC. Then we're going to go to triangle ABC. That's the next one. Now A is over here, B is over there, and C is over there. So it's actually a triangle where not all of the lines are in the figure, because the line from A to C is not there. We do know that this is 3, and we know that this is 2, this is 2.5, and this is 1.5. So if you want to know the whole length from A to B, you have to add these three lengths. This is 4, 4 plus 2 is 6, so we do a half times 6 times the matching height, which is 3, and there you get 9. So that area should be 9 squared centimeters. And now we get to some difficult questions, D and E. First exercise D, it says calculate the area of trapezium AECD. Alright, so here we have AECD, so like that. So you need to know how to calculate the area of a trapezium. So the area of a trapezium, let me write down the formula for you. There was a half times the sum of the parallel sides. I mean, you learned this when we were doing chapter 2, but maybe you've forgotten this formula again. So it's a half times the sum of the parallel sides times the height, right? So if you take a look at this trapezium, then the parallel sides are this length and that length, because they're parallel. Well, this is 4.5 and this is 2, so we need to add them. So the area for trapezium AECD is a half times, in brackets, 4.5 plus 2, because we need to add this length and that length, and then times the matching height, which is still 3. Now if you calculate this, then you will get an area of 9.75 squared centimeters. Alright, let's do exercise E then. It says point Q is on edge AB, so here's edge AB, point Q is on here somewhere, in such a way that the area of AQD, so here we have A, here we have D, and then Q is somewhere on this thing, is exactly 6. How long is AQ in centimeters? Okay, so if you take as an example, let's take a look at point E over here. If it were triangle AED, so like that, then this would be the matching height. Right? Now if I move point E a bit, the matching height doesn't change. The matching height stays 3. But depending on where E is, this length is bigger or smaller. Now there is a Q somewhere. So for example, Q could be here. And we don't know exactly how long this length is. But we do know that if I make triangle AQD like that the area of that triangle is 6. Right? If you calculate the area of triangle AQD, then what you do is you do a half times the matching height, which is 3, times the side that we don't know. We don't know how long AQ is because we don't know where point Q is exactly. But the outcome, we do know the outcome. The outcome should be 6. Now if you do a half times 3, you get 1.5. So 1.5 times something should be 6. And then if you do 6 divided by 1.5, you get 4. So this question mark should actually be 4. That means that length AQ should be 4. And this is how exercise 24 works. So kind of a difficult and long exercise. Also, this is not the end of the video yet, because I also want to talk to you about exercise 25. And with exercise 25, we need to calculate the areas of these shapes. Now, I do want you to try it yourself first, right? So if you're watching this video and you haven't tried it yourself yet, please try it yourself first to see if you understand. First, this one, area A. This is a parallelogram, and the area for a parallelogram is the side times the matching height. And you don't have to do times a half or any of that with a parallelogram. Well, we know that this length is 6.5. We know that this length is 1.5. So this whole length is 8. So the area for that shape, the area is just 8 times 2.6, and then we have it, and that's a 20.8 squared centimeters. Area B, that's this shape. This shape is a triangle. So we do, for the area, we do a half times the side, and the side is 6 in total, times the matching height. So you get 12 squared centimeters there. For area of shape number C, that's also a triangle. So we also do a half times the side times the matching height. This one's a bit more annoying though, because the height is outside of the figure. Here you see 2.5 and 1.4, right? But only 2.5 is part of the triangle and the 1.4 is not. So that's why we use 2.5, but we do use that length. We do use 4.4. Now if you calculate this, then you will get 5.5 squared centimeters. And then the last one is area D. So the area is, this is a trapezium. And the formula for trapezium we wrote down earlier, it was a half times the sum of the parallel sides and then times the height. Hopefully these numbers are still a bit okay to see on the video. But the sum of the parallel sides is 8 and 3. When you add them, you get 11. And if you can't read these numbers that well, you can also see them in your book, of course. And the matching height for this trapezium is 4. So you have to do this times 4. So there you get 22 squared centimeters. So these are the answers for exercise 25 and also the answers for exercise 24. So I hope everybody understands it. And thank you for watching. Bye-bye.